Explore section focuses on the functional requirements, non-functional requirements, and constraints that will be present during the Arduino task. It describes what the digital solution needs to complete, how the digital solution will complete what it needs to do, what the digital solution needs to do to successfully solve a given problem, and what may limit the digital solution from achieving its task. Mind maps are a great way of visualizing points that can be used to translate ideas from the mind into a visual picture. The mind map below depicts the functional requirements, non-functional requirements, and constraints that will be present during the Arduino task. Functional requirements are necessities that relate to the technical functionality of the system. Non-functional requirements are necessities that are specified criteria. These can be used to judge the operation of a system. Constraints are the limiting factors of the assignment. Some examples of constraints are, but not limited to, data collection, process, time, resources, and malfunctions. Below is criteria that can be used to form a knowledgeable understanding of what the task requires. Below also contains constraints that may be present during the assignment. The criteria includes prescribed criteria and self-determined criteria. Prescribed criteria is required characteristics of a project as defined by the target audience. Self-determined criteria is desired characteristics of the project. Constraints are restrictions that may be present in the task. Prescribed criteria for this assignment are: the prototype electronic device must be developed via the Arduino Uno. The device must be designed for a specific purpose. The device must function effectively for the purpose intended. The device is to be programmed to utilize inputs and outputs using digital and/or analog pins. The device must be programmed using logical and efficient code structures. The device must be programmed to collect, store, and process input data. Self-determined criteria of the task were efficiency of the Arduino completing all the tasks, accuracy of the Arduino completing all the tasks, accurate coding and programming, the device must function in all environments, Arduino is durable at completing tasks, and the digital solution is able to convert data to the metric system. Constraints that were present were time, ability, component malfunction, resource accessibility, and dangers associated with the use of electricity. The develop section is about how, via the use of sensors and algorithms, a digital solution completes a task. The section follows how each sensor works and how the components will work together to accomplish a given task. The section also contains an algorithms of how each component/sensor works. The components work together to complete a given task. For example, if the light sensor detects a low amount of light, then it will activate the LED lights. The design of prototype electronic device section is about how the sensors and components on the digital solution work together to complete the Arduino task. It will provide an explanation of how the components work together during the task by detecting light levels, detecting temperature levels, and automatically feeding the livestock via the use of timing implemented in the code. The prototype electronic device imitates a real-life application through the use of the Arduino. The device needs to successfully activate a fan when it is too hot, open an automatic feeder after a certain amount of time, and turn on a light. The components will work together to dictate the outcome of the other components. The fan will activate when the temperature sensor detects a certain amount of heat. The automatic feeder will open once a certain time variable has been reached, and an LED light will activate once the light sensor detects a low amount of light. The Arduino Uno is an electrical hardware component that is able to interpret inputs such as a button or the amount of light detected from a light sensor. The Arduino Uno then outputs this data to a module, causing it to perform an action. For example, activating a motor or turning on an LED. The Arduino Uno will help perform a given task as it will serve as a data collector, process, and dictate outputs. The ambient light sensor works by detecting light levels on a sensor, which then sends a variable to the analog output. As less light is detected, the analog output variable will decrease, and if the sensor is detecting increased light levels, the analog output variable will increase. This will help complete a given task as it will allow data to be collected in correlation to the LED. The 5mm LED works by receiving data from a module and then activating the diode to emit light. This will help complete a given task as it helps provide light for the livestock. The microservo works by receiving data from a module and then activating a DC motor, a gear train, and a potentiometer to perform a given task. This will help complete a given task as it will allow the livestock to be fed. The fan is a module which is powered by a motor to spin blades. This will help complete a given task as it will help cool down the livestock. Sorry, that should have been that one. The LM35 temperature sensor works by detecting temperature levels and then relaying that information back to the Arduino Uno. This will help complete a given task as the data from the temperature sensor will decidedly dictate what the fan will do. The resistor works by controlling the current that flows through it towards a component. If no resistor is put in the electric circuit, there is a risk that a component will be damaged. This will help complete a given task as it makes the electric circuit safer, as well as helps components from being destroyed. A piezo is a component that releases a sound at set frequencies. This will help complete a given task as it will be used as a buzzer for when the fan activates. A DC motor works by exploiting electromagnetic induction. The motor features a horseshoe magnet and a turning coil of wire called an armature. This will help complete a given task as the DC motor will help spin the fan blades to decrease the temperature for the livestock. A flowchart is a pictorial or graphical representation of a process that occurs over time. The purpose of flowcharts are to communicate how a procedure works or should evidently work in a more simplified way. Essentially, a flowchart avoids jargon and makes it easier for people that are non-familiar with the content to understand. If you want to look at the algorithms, you can pause the video. The Generate section designates information to the construction of the digital solution, what the components do, and a video demonstrating how the digital solution functions during the Arduino task. This section is about providing visual reference of the digital device based on specific design components from the components section. If you want to look at these, you can pause the video. The coded components section is about the components that have been programmed to perform a certain task. The section will explain what each part of the program does and how it dictates what output it will cause for the other components and/or how it will affect the digital solution physically. The algorithms in the algorithm section must relate to the code. Number 1. This is a library and imports code as well as functions. This can be used for the code to be more efficient and shorter whilst completing the same task. This was used to save time and make the final code more efficient. Number 2. This code declares the variables and their values, which will be used later in the code. Number 3. The setup function runs once and is called when a sketch starts. It is used to initialize the variables, pin modes, start using libraries, etc. Number 4. This code imports code from a library, so the final coding is smaller and more concise. Number 5. The loop function consecutively loops any code within it whilst the board is active. Number 6. This code relates to the servo motor. It works by turning the micro servo 95 and then waiting 3000 milliseconds, for which it turns back to 0 and waits 10,000 milliseconds until it releases the food again. Note: in a realistic situation, the delay for the micro servo would be much larger than 10 seconds, but for the purpose of creating a video, the delay was made to be much smaller. Number 1. This code declares the variables and their values, which will be used later in the code. Number 2. The setup function runs once and is called when a sketch starts. It is used to initialize variables, pin modes, start using libraries, etc. Number 3. The pin mode sets up ports for the Arduino to output or input data to or from the components with what to do. In the code, pin mode A0 collects data from the temperature sensor, pin mode 8 is connected to the fan, pin mode 7 outputs data to the speaker, and pin mode 9 outputs data to the LED light. Number 4. The code starts a serial connection between the computer and the data that is being received. The data that is displayed on the screen, for example, if it was collecting data for the amount of light detected, when there is not much light, it will say 1 or 2, and if a light is shined on it, then it will say 12 or 13. Number 5. The loop function consecutively loops any code within it while the board is active. Number 6. This code first converts the readings of the temperature from Fahrenheit to Celsius. The serial print allows the readings to be displayed in the serial monitor with the measurement in Celsius. The if statement makes it so if the temperature detected is more than 27, activate the fan. Once the fan is activated, the next line of code executes the LED to activate. Then the piezo makes an alarm sound to warn people that the heat is too high and the fan is activating. The else statement executes when the temperature that is detected is less than 27 degrees. It makes the LED stay off and the piezo to not activate. Number 1. This code declares the variables and their values, which will be used later in the code. Number 2. The setup function runs once and is called when a sketch starts. It is used to initialize variables, pin modes, start using libraries, etc. Number 3. This code collects and then displays the data for the amount of light that the ambient light sensor is receiving. The code also outputs that data through pin mode 9. Number 4. The loop function consecutively loops any code within it whilst the board is active. Number 5. This code helps read the data that is being collected from the sensor and then displays the data on the computer screen so it can be altered. The data is then relayed to the Arduino, where it is there processed and it determines if the LED should turn on and how bright it should be. might not have heard it, but during that last video, the piezo was making an alarming sound. Anyway, the evaluate section focuses on testing and refinement, as well as evaluation and recommendations. The section is about evaluating how well the prototype electronic device performed during the Arduino task and making adjustments to make it better suited for the objective. This section is about testing the digital solution. It will log trials, expected outcome, actual outcome, refinements to prototype robotic device design, refinements to algorithms/coded components, and notes. It can be used to see the development of the electronic prototype device and errors that have been refined throughout the project. Once again, if you want to view this, you can pause the video. The evaluation and recommendation section is the evaluation of the criteria and the recommendations for future attempts. The evaluation of criteria uses the prescribed criteria, self-determined criteria, and constraints mentioned earlier in section 1.2 to evaluate how successfully the device met each criterion. Once again, if you want to view this, you can pause the video. Recommendations are vital for the experimentation and success of future developments for the Arduino Uno task. It can be noted that the digital solution performed successfully and satisfied each of the prescribed criteria. The Arduino was successful in utilizing sensors that would then dictate the action of other components. The device activated the fan when a high temperature was detected. Once the fan was activated, the LED light shone and the piezo made an alarming noise. When a low light level was detected through the use of a light sensor, the Arduino processed this information and then activated the LED. Every certain amount of time, the microservo would rotate. The components in the digital solution successfully met the prescribed criteria. However, two factors can be improved on in the Arduino Uno assignment. Firstly, the digital solution was unable to be tested in different environments. Obviously, the prototype electronic device cannot be taken to different environments in real life. However, different environments can be mimicked. For example, if the digital solution needs to be tested in a cool environment, it can be taken to a room with air conditioning. Oppositely, if it is being tested in a hot environment, during the middle of the day, the digital solution can be taken out onto bare field. Secondly, some components were not available for the task. The transistor was unavailable as it did not come in the starter Arduino box that every group had. Whilst the transistor was not needed in the end, the device still functioned appropriately. If it was needed, a transistor could be purchased or other components could be used as substitutes instead. In a real-life situation, the digital solution would be much bigger than what it was created for the assignment. The digital solution meets the ends of the target audience, meets the needs of the target audience and client as it successfully completes the livestock task. It does this by successfully utilizing input structures as well as collecting, storing, and processing input data. For future developments, students should know how to use components that they may have not learned throughout the term, as this will allow them to expand their potential for what they create in the Arduino task.